A literal beacon of light is on the horizon for spacecraft exploring our solar system and beyond. Once considered science fiction, pulsar navigation is making headway as the next best method for meandering through deep space. Pulsars, magnetized, rotating neutron stars or white dwarfs, emit electromagnetic radiation with impressive regularity, making them akin to celestial lighthouses. Several decades ago, scientists began wondering if the right kind of spacecraft could infer its own location based on the time that elapses between signals from multiple pulsars. But until now, no one's been able to make this fantasy a reality. A pulsar in the constellation of Vela. Here's Robbie Gonzalez, reporting for Wired. Keith Gendreau, an astrophysicist at NASA's Goddard Space Flight Center, and his team performed the demonstration quietly last November, when the Neutron Star Interior Composition Explorer pulsar measuring instrument the size of a washing machine, currently aboard the International Space Station, spent a weekend observing the electromagnetic emissions of 5 pulsars. With the help of an enhancement known as the Station Explorer for X-ray timing and navigation technology, aka sextant, NASA was able to determine the station's position in Earth's orbit to within roughly 3 miles, while it was traveling in excess of 17,000 miles per hour. Deep space missions today navigate using a global system of radio antennas called the Deep Space Network (DSN), but the DSN has limitations. It becomes less accurate when a spacecraft gets further into space, and it's not good at measuring sideways movement. The network is also getting crowded, which means scientists and engineers need to come up with alternative navigation methods. Luckily, pulsar navigation doesn't require data transmission with Earth, so a spacecraft equipped with this ability is more flexible than a spacecraft without it. We could eventually see more real-time missions behind our sun, or to the edge of our solar system and beyond. Location information would be driven by self-determined coordinates, and a spacecraft wouldn't have to constantly wait for ground-based instructions from humans on Earth. Other autonomous positioning systems are in the works, too, and they're experiencing varying degrees of success. The challenge will be finding the right combination of tools that don't happen to weigh a few pounds too many, that give astronomers and engineers a suite of options for exploring the cosmos.